All right, good evening, everybody. My name is Jason Anderson, and I'm the coordinator for the Cognitive Computing Meetup Group. So welcome. I know we had a lot of new members join recently, so welcome if this is your first meetup, and welcome to everyone else who's returning as well. So tonight we have Katherine with us here. Katherine works at Stitch Fix, and she basically works with human recommenders and helps train them and make them useful within Stitch Fix. And so Stitch Fix is a personal, she'll talk more about it, but basically style recommendation personalized to an individual user, and they use a combination of machine learning and humans in the loop to make that happen. So before working at Stitch Fix, she got her PhD in cognitive and information sciences, and she was working primarily on shaping human behavior using cues, attention cues with humans. All right, so without further ado, we have Katherine.
Thank you. I had originally planned to start by introducing myself, but that seems to have been done now. So, I'm a data scientist, recovered academic, and I work at Stitch Fix on our algorithms team. And at first, I was a little bit hesitant about this particular talk because I talk a lot about humans, but it's in service of interacting, like meshing humans with algorithms, which hopefully is relevant to all of you. So I sort of want to set the stage by talking about our background of human computation. So I'm under algorithms, but I'm under a human computation team, which is sort of a specialty sub-team. And the idea behind human computation is that you have humans and computers working together to ultimately create a better product. So computers do some of the lifting, humans do some of the lifting, information flows between them, and ultimately, hopefully, your client or your customer ends up with a better outcome. It's a pretty interdisciplinary field. It's still pretty nascent. You get some combination of crowdsourcing, wisdom of the crowds, machine learning, recommendation algorithms, cognitive science. I found my original home over here, but at Stitch Fix on our HCOM team, we end up doing a little bit of everything. A lot of us have human behavior backgrounds, but we also have experience building machine learning algorithms. So there's a lot of companies that are starting to leverage this idea, realizing that humans and computers are good at really different things. Every company out here has found some way of offloading some of the work to humans while giving computers other tasks. I'm going to primarily focus on Stitch Fix because that's where I am and that's where I have interesting stories from. So just to sort of set the stage and give a bit more background about our business model and why it is we bothered to do this. Basically, we start with a computer algorithm, a recommendation system. That recommendation system does a lot of the heavy lifting. It does things like the structured data, calculates purchase probabilities for an entire warehouse, those sorts of things. It creates a sublist of, say, 50 items, give or take. Those get passed to our human stylists who see a client profile, they see her stories, they see a lot of unstructured data, notes she's written. Of those, say, 50 items, she selects 5 that she thinks goes together really well. She writes a note, they go in a box that gets shipped out to our client. The client tries everything on, keeps what she loves, and sends everything back that she doesn't. So we have a really high motivation to make sure that what goes out in that box is really optimal. Interestingly though, she also gives us feedback. So she tells us what she loves. She gives us thumbs up, thumbs down. She gives us little notes about things that she loved or that she didn't love. And that feedback goes back into the computer algorithms as well as the humans. Humans and computers are good at really different things. And this is sort of the core realization that we had when we designed the system. So computers are good at heavy and repetitive computation, obviously. That's sort of like their strongest suit, right? So again, those purchase probabilities for an entire warehouse, if you gave those to a person, they might be able to do it over a really long period of time, but it's probably not the most optimal way to do it. Large-scale working memory tasks, if you want them to hold 1,000 different features in mind, probably not going to go super well if you're dealing with a person, but super optimal for a computer. And large-scale long-term working memory tasks, or long-term memory tasks. So again, things like remembering those purchase probabilities a month later. Humans, though, are good at things. We're working on making computer algorithms that are better and better, but they're not perfect yet. Things like context sensitivity and nuance. If a client tells you that she's going to her mother's 60th birthday and she wants something special, what does that mean? How does that relate to where she is in the country? How does that relate to whether or not she's a mom? Those are things that humans are just a lot better at still. Aesthetic judgment, what looks good, especially if it's something like a current trend or clothing styles. Relationship building. Our clients, and many clients, love a human touch. They'll pay a premium to know that a human has been somewhere involved and thought about you. Novel inferences and unstructured data, just sort of in general. So those notes that get written, photos, her Pinterest board. Humans can take information out of that computers are still not ideal for. Interestingly, humans and computers have a lot in common and some very important differences. So we've started thinking about humans, our humans in the loop, as processors, as algorithms that make predictions. So both types of systems process information to make recommendations. They take in data and they output a prediction. They also make those recommendations also get better with better features and better data. Both need to be trained and tuned, and this is something that I'll talk about in the human context as we go forward. The differences sort of will also shape this talk. So with computers, you can specify those internal mechanisms. You can tell it exactly what you want it to do, and you can tell it all of the information you want it to consider. Whereas with people come with a lot of history, people come with a lot of mechanisms. You can only change it so much, and they can consider the entire world. So one of our stylists work remotely. She could be working at home, and she could have a kid pulling on her leg while she's working, say, and that's information that you can't really predict that she's also going to be thinking about while she's making recommendations. So a lot of the stuff I'm going to talk about today sort of helps to deal with these differences that make people particularly special and unique, and how you can optimize their behavior with those in mind. So I think that there's sort of three different stages to this idea. One is determining what people are processing, what information they're considering while they're making a prediction. Then determining what they should be processing, because what people do and what people should do is often very different. And then ultimately changing or shaping what they're processing to be closer to that optimal idea. I do sort of want to note that we look at this as a holistic process. So we don't do this once, we do this on an ongoing basis. So we figure all this out, we make more recommendations, we deliver those recommendations, we receive more feedback from our clients, we put all back in the loop and continue to optimize. All right, determining what they're processing. Here, your whole goal is really to figure out what your human workers are attending to while they're making their recommendations. If they aren't attending to some piece of information, then they're not making a recommendation off of it. And by feature here, I mean exactly the type of thing that you would use when you're talking about a traditional machine learning algorithm. Some piece or type of information. If someone isn't attending to something, but you're showing it to them anyway, you could make your workers less efficient, so you could slow them down. And if you pay by time at all, that's not a great idea. You want them to be efficient, that you use their time effectively. You can also fatigue them. So most of our stylists, for example, won't just do 10 minutes worth of work. They'll do a few hours worth of work. And over those few hours, you want to make sure that you're not putting them under unnecessary stress to make sure that their recommendations over time are just as good as when they started and weren't tired. There's also a possibility to lose lost opportunities with an opportunity cost for including something that isn't useful when in place you could have put something more useful, right? So people have a limited amount of attention. They can only consider a certain number of things at any given time. And if you have a bunch of noise in there, then perhaps you aren't showing something else that could be more useful. Stage one, I know this seems really obvious, but talking to your human workers goes a really long way. This is sort of like the equivalent of saying, like, plot your data before you do anything. Everybody knows it's a good idea. A lot of people skip the step. So just getting their intuitions about what they think they're doing. They're often wrong, and that's fine. But it'll sort of like condense your search space as you're trying to figure out what exactly they're considering. There's also online observations. So I'll sort of define these in a second, but these are methods that help you to reduce your hypothesis space, okay? Again, just like talking to somebody. They're higher granularity observations. They're also time dependent, so they can tell you when something is being considered and not just what is being considered. And these are really good for exploration. They are not the final say, but they're really good objective ways to start. Mouse tracking is an example of this. This is our simulated data, but you could imagine somebody going to our landing page and going to schedule one of our shipments, and you can take a look at where they've laid their mouse for the longest period of time, and all of these lines might be trajectories between points. It's a really cheap measure of human attention. It's extremely non-invasive, so most people won't really notice that you're collecting that data. And it's really easy for widespread deployment. Most browsers, JavaScript, can do this really easily as long as you have a data warehouse that can handle it. Scrubbing the sort of data and dealing with it afterwards can be a little bit tricky, but it's a really, especially for something like exploration, it's a good place to start. There are some softwares that will just spit out something like this for you so that you can take a look at it rather than having to go through all the mining processes. So for example, this big circle would tell us that the user had spent a lot of time considering this sort of middle point of the calendar, and that might be useful.
Is there a relationship between where they point their eyes and the position of the mouse? Is this established?
Yeah, there's papers on it. I would have to look at the citations for you, but there's been a ton of research suggesting that this is a pretty good, people have a tendency to move their mouse where they look. However, if you don't trust mouse movements, eye tracking is another really good option. So eye trackers basically do exactly what you're seeing. They sit on your head in some sort of way, and they track where your eyes are moving and where your visual attention is going.
I have a quick question.
Yeah.
Before I ask my question, I think if someone hide their laptop or cell phone's camera, you cannot do any eye tracking.
I'm sorry, what?
If they hide their cameras of their laptop or cell phone, you cannot do any eye tracking or mouse tracking.
Oh, so an eye tracker.
Yeah, but anyway, that's not the issue. My question is, it looks like you are doing traditional machine learning. So I'm just curious, how do you do in terms of feature extraction and visual union?
That's the rest of this talk. So bear with me, and if I haven't answered that by the end, re-ask it. Okay. I just sort of wanted to start with exploratory methods because it can often be really hard to know where to start. These are sort of ways of just starting to get an idea of what people are doing, and then you can go into more like A/B testing sort of frameworks later on. I wanted to point out that the use, give a little quote about why you might use something like eye patterns. Visual search patterns lie somewhere between random and systematic. Humans will attempt more systematic searches, but will still suffer from imperfect memory. So eye tracking is particularly good because it is resistant to strategy. So even if you don't want to look at something, oftentimes you will end up doing so. So somebody, say, might not want to give Twitter that attention or something like that, but they end up doing it anyways. They're also deterministic, so once eye movements start moving, they finish where they were meant to go. That is determined by the brain, and you don't really get to say, stop, I don't want to look there halfway through the eye movement. As a result, they're also higher accuracy than something like mouse tracking, so there is a little bit of a disconnect between where your mouse goes and where your eyes go. This is a lot more of a definitive way to make sure that you know where that visual attention is being sent. This can give you more sets, lots and lots and lots of sets of XY coordinates and durations, but there's also a lot of software out there that can be really friendly and give you things like heat maps. So you would know that the person had spent a lot of time staring at the middle of this calendar and less time sort of, if we really wanted them to think about gift cards and we saw no activation up there, that would be a sign that we hadn't done a good job of telling people to look there. You can also do something like specify what's called an area of interest, or an AOI. And that's basically, you can use XY coordinates to draw a little box around whatever feature you think you might want to study or you might want to know whether or not somebody is considering. In this case, we can consider the AOI that central part of our calendar. All right, so now we might have an idea of what people are considering, the types of information that they might be thinking about. But as I mentioned earlier, that can often be very far from what they ought to be considering. So perhaps there are better things to be thinking about while you're making a decision. This just tells you what they were considering, not whether or not it was good. So there are ways of also determining that. These are the features that you would want to select, right? You can think about it a little bit like feature importances on a random forest, right? There are features that it could select and that it could think about, it being a human worker in this particular case, and there are ones that you might have access to which actually make it worse, right? That are sort of like a decoy in some sort of way. And getting a read on that would be helpful. So, step 2, determining what they should be processing. Here, given the features that they're using, we want to know which ones lead to the best recommendations. So here you're interested in overall performance, and you can optimize for whatever performance is important to you. So true hits, false positives, false negatives, whatever it is that you want to increase or minimize, you can do that. You can also do things like processing time, so worrying about how long somebody is spending time considering a piece of information. So the logic here is that workers may vary in what features they use, but you can look for correlations between their attention to those features and positive metrics for whatever metric you want that to be. This allows you to learn the optimal features across your current candidates, right? So current candidates would be things that you already think they might be considering. This is where that initial exploratory work would come in really handy. So one way of doing this is what we call feature dropout studies. So very similar to when you're trying to figure out an optimized algorithm, you can leave one out and then compare accuracy. This looks a lot like an A/B test. The logic is pretty similar. So you show a feature to one cell and you remove it for another, for example. And if there's a positive difference in performance that you see between those two cells, then you can be reasonably certain that as long as you've controlled your experiment correctly, that feature that you removed is actually causing better judgments to be made. Optimal conditions for this, and I say optimal, not the only conditions, but definitely optimal, is a highly controlled, like, offline environment where you can control all of the factors that might also influence, or confounding variables that might influence that metric that you're interested in optimizing. So this sort of offline environment would allow something like true participant randomization, repeated measures, so measuring the same person multiple times to get individual differences between participants, and high what we call internal validity, which is an experimental term that basically just means your ability to draw causal conclusions between the change that you're making and the results that you're seeing. So we use something, I can't show you the real thing, but I got this lovely little cartoon that looks a lot like the thing that we use cleared for public display, but we can call this like our styling lab. And we have programmed it to look a lot like our live styling environment. And we give a whole bunch of information about something like our clients, task relevant background information. Maybe this is the feature that you're interested in, whether or not it makes a difference. And then we, like a lot of companies, have historic data, right? Like, we know what we've sent our clients and we know what they've purchased and what they've sent back. Our stylists, however, have not seen every item that we've sent, nor do they know what the outcome of every item was. So we can do something like show those items and then ask them to predict whether or not a client bought it. And then we can say, okay, well, give us a response. We can look at accuracy, we can look at reaction time, we can look at confidence, we can look at basically anything that you can measure in a browser. And this will give you a measure of how well they're able to make a prediction. Okay, it's kind of like backtesting with a machine learning algorithm.
Okay, here's a quick question. So all the feature you mentioned here, there are visual features that's available in the browser. I just want to get that clarified. So it's not a language feature or whatever other features.
So these are visual features. You can also manipulate the content of or the representation of those features. So, you know, you can manipulate how you're representing unstructured data, whether you interpret it and do some feature engineering to sort of boil it down. We do that sometimes. There's a lot of times where, you know, imagine a client gives us thousands and thousands and thousands of pieces of unstructured data. We often will try to engineer ways of boiling that down in some sort of way. So we can test different iterations to see how that goes as well.
So it looks like you need to do a lot of manual tasking, because so the features are actually, you know, feature extraction taken almost all manual. So why not use deep learning? If you adopt the deep learning, there are a lot of feature engineering can be automatic.
So sometimes we'll use
I'm just curious, you know.
Well, sometimes we'll use something like deep learning
this kind of problem?
You mean to make recommendations?
Yeah.
Well, that's sort of at the heart of our business model, right? So we found that we can make better recommendations by combining the two. Deep learning gets you a long way, but it's still not good at everything that people are good at, right? And the parts of the job that we think that the humans do best are things like putting together a really complicated outfit complete with really nice shoes, right? Like, algorithms can take a guess at that, but there's certain things that they're nuances, for example, they're just gonna miss. And we take pretty good pride in the fact that we have over 3,500 remote workers that we can give jobs to and that can contribute. And a lot of them, large proportion of them have backgrounds in fashion, university degrees, and they're both bringing a lot of knowledge that for us to amalgamate in even a deep net would be extremely difficult.
Yeah, I wanted to ask, did you say that you actually do show final selection results to those who recommended, or you do not?
Show them?
Yes.
So imagine this is like we'll send out an email, we'll say we have a new study for you guys to do. And it'll be a platform like this, and we'll have a couple of items. So some sort of forced choice task where we say, make a prediction for us, right? And the items that we're showing are things that we know what the outcome was. We've sent them out before, we've got that historical data. So let's say, let's make it even simpler. There's only two items, one she bought and one she didn't, right? Same client was sent both items, one she did, one she didn't. We can then look at their accuracy. So
That I understood.
Yeah.
What I asked is whether somebody who made the final selection of 5 to 6 samples.
That's
you
the human
should
sample.
in the box, right?
Yes.
And then, do they get exact feedback what
Yes.
was chosen?
Yeah. Yeah, they do. I mean, we have many clients, and a stylist would not be capable of remembering the outcome for every one of their clients. We also, when we do these experiments, we obfuscate who the actual client was, so we take out her name, we take out information that we think is absolutely not useful for this particular question.
But you can leave just ID, and so when the stylist recommends second time.
Oh, yeah.
Yeah.
During the online recommendation process, yeah, we show things like history. So a lot of our clients really like that they have a relationship with their stylist, so they'll get the same stylist over and over and over again. We've had stylists who've we've had clients who've had the same stylist for 5 years now, and they know that client super, super well. Of course, we also have clients who are sending something, or who are seeing a stylist for the very first time. So it's a pretty rich combination.
Yeah,
So
I know
you have-
somebody who uses your service.
Yeah.
So I know your reaction and how it works.
Okay, good.
So it looks like you have crowdsourcing. Your customer can manually label the data carefully. My question, you also, it looks like, what you are telling us, you're also supporting real-time recommendation, real-time. Right?
Yep.
What is, in terms of data size, is that terabyte or terabyte? And how do you divide among hot data, warm data, and cold data? I believe you are adopting data, right? But you are storing your data from day one, and you never do.
So we collect a lot of data. Some of it is more discrete, so things like, did she buy it, did she not? We also collect things like, that's both at the item level and then fix, like shipment-wide.
Never
metrics.
open. You store your data from day one, and you never delete.
We have data, we have big, large
So
data
that's
sets.
terabyte. Right?
I can't, there are certain things I can't give you. Sorry.
Do you show a picture of a person to somebody who selects the data?
We've explored that. We do have, some of our clients can like if you have the web app, you can upload a selfie. We also, our clients can keep things like Pinterest boards, and some of our clients get especially creative and upload selfies of themselves and everything they've been sent to show feedback that way. Our clients get extremely creative with how they give feedback, which is one of the reasons that having humans in the loop is so meaningful, because, you know, an algorithm would have a hard time figuring out that the client is using that Pinterest board in a really unusual way, and it isn't just tagging items that she likes, but, you know, items that she likes that she's wearing. And that might be something that you might want to note in a note or something like that. So the human aspect there is extremely valuable for us. All right, so after you run your study, your analysis can sort of continue like you would a normal A/B test. So we're really big on mixed models, so you can do something like regress correctness, whether or not that prediction was correct on the condition that they were in, with some sort of grouping factor for your participant ID. If you see condition differences, then the logic would follow that feature that you were showing or dropping out promotes better recommendations. And if it doesn't, then it's either not considered or it makes no difference for the recommendations, even if it is.
Excuse me, you said that you pre-select 50 items, so also, and then final decision is up to the person. So, out of how many? 50 out of how many?
We have 4 warehouses across the US. I can't give you exact numbers of how many SKUs are, but let's say many. We have warehouses. Okay, this is also a place where you can sort of enrich your research program using those same sorts of online observations that I was speaking about earlier. So what you get here is the ability to demand whether there are certain times at which a certain feature is beneficial. So not just is it useful, but maybe it's most useful at a given time. And the ability to figure out how that information is searched for. So maybe they're using it, but maybe they have to go through 5 things to get there. And maybe there's a way that you can then work with your UX department, for example, in order to optimize that environment a little bit more. Another quote for you, just to sort of give you an example. Tracking eye movements during visual inspection may lead to predictive analyses if certain recurring patterns or statistics can be found in those collected scan paths. For example, an expert inspector's eye movements may clearly exhibit a systematic pattern. If so, then this pattern may be one that can be used to train a novice. So the idea is, if it's helpful, make other people do it, right? So you would start with a similar sort of study to determine correlation. So we'd be in our same little exploratory styling lab combined with an eye tracker. And you might be able to notice that, okay, while this person was making the decision and they got it correct, they happen to often look at things that the client said she loved, right? So she's looking at the history and she's looking at things that were successful, and then she's making a better a decision afterwards. You can also code your items. This would be very exploratory. This wouldn't be large scale. This would be small scale. This is what we would call pilot work, right? But you could code it and you could say, okay, so they're not necessarily the same department, and they're not necessarily the same color, but so our hypothesis here is that it's things that she loves. There are multiple metrics that we might track during this. We can look at overall trajectories. There are packages that would help you to analyze that sort of data. Eye tracking R is one of them. You can look at saccade paths, so where the next movement is given where you started. Fixation times and location, so where on XY coordinates somebody was staring at for a particular time. And then any of those really could be correlated with success. Similar to our previous model then, what you could do would be correct, and then some number of fixation or eye movement metrics that you might be interested in. So for example, fixated on loves, fixated on color matches. Then you can look for significant factors in your model and use those to motivate a larger scale feature sort of dropout study. So for example, then we might follow up, we might work with UI, we might say, okay, well now what happens if we actually manipulate this and we don't just look for correlations? So now we'll only show things that she loved and we'll look for differences in how that person did rather than if they saw everything as they traditionally did. So again, then you can do your correctness predicted by condition. And hopefully what you get is sort of an idea of which particular features and manipulations are particularly helpful for making these decisions. Okay, so now you're sort of armed with knowledge about how things are going to go and what features are useful, and now you want to know how you can actually shape that information processing with your humans. We will often take these sort of smaller scale studies and roll them out to full online tests. For us, this is a way of doing a lot of development before we actually can affect client outcomes. We call it de-risking a lot of the time. We might have a hypothesis, but we want to make sure that we don't adversely affect our clients before we have a pretty good understanding that we're actually going to be improving their worlds. So for us, this often looks like our styling lab, that thing I was showing you, followed by some full live A/B test that affects live clients. And that also helps us to be sure that our smaller scale research studies also map the findings and the patterns of the effect sizes that we would expect map onto our full live world. So one thing that I sort of want to drive home is that behavior shaping is to humans as tuning is to computer algorithms, right? You can start with something, but there are ways of making it better. These changes can be things like that are in the moment. So you maybe want to work with UX and make display changes. You can direct visual attention in some sort of way, change colors, change locations, make things flash, whatever. They can also be more sustained, so you can train your people. If you have a workforce that is something like Mechanical Turk, that is doing like really short time engagement jobs, this is something that you might want to exploit. If you have hired workers and you've invested in them, as Stitch Fix has, training them. We care about their longevity, we care about maintaining them and keeping them happy and making them better at their jobs and making them better than when they started with us. So just to sort of give an example, perhaps we found out that loves are super helpful. Again, we could work with UX, we could exploit what we know about human perception. Again, I highlight work with UX. That's what they're there for. Now, we look at training sort of as a cyclical relationship with testing. So understanding what our stylists are doing, determining the content they should be considering, and determining what content is most useful is sort of stage one. Then we can go ahead and optimize their behavior within our styling environment, within their online work environment. We can draw their ongoing attention to important content. So whatever that content might be that we think is correlated with success. And we can reinforce key concepts. So for, as you pointed out, they do get feedback. But think about how long it takes for them to get feedback. We ship they style a fix. That fix gets packed, gets shipped. They get it within a few days later. The client has 3 days to check out. She then writes something, and then at some point, that stylist within the next couple of weeks can go ahead and take a look at that feedback. If this is your constant job, this is a lot of time between the time that you're making the decisions and the time that you're getting feedback. For humans, that really matters, right? Immediate feedback is really useful. So that's something that we sort of had in mind when we were thinking about how to go ahead and train our humans.
But it shouldn't matter actually, because when you deliver back this feedback, she either way, longer or shorter, she sees that this ID, rejected or accepted such and such items. At the moment, she makes the next decision. So isn't that it's pertinent here that to get this feedback before she makes the next decision?
Sure. So I think one of the things is that we expect that our stylists are making decisions for reasons, right? So for example, with busty clients, tighter fitting clothes are good, right? But what is considered a busty client has something to do with your hip and your weight ratio and your chest ratio, and that's a pretty complex integration for humans. That's sort of like a relational structure that they have to reason over, and they might be able to make that decision in that period of time, and they might get it right or wrong. But to then 2 weeks later, after they've styled many more fixes or many more shipments, to remember exactly why they thought that was the case, that might be a little bit hazy, right?
But they don't have to remember. I would assume it would be in the profile.
So the information is there, but we don't interpret all of the information for our stylists, right? So like we could give something like shirt size, dress size, pant size, but we don't say you have to send this item because she has this particular ratio, right? Those are some of the decisions that our humans can make.
Yeah, but you can give multiple choice, for example, peer or etc.
Sure.
Hourglass, etc. Right there.
Sure, but there's still decisions. They're still making tons and tons of judgments about why an item might be good for somebody, and then to ask them to remember that 2 weeks later, human memory isn't. They're not going to remember that. If they only ever styled one shipment, it would be very memorable. But we've had stylists for 5 years who have shipped many fixes over their tenure. And to ask them to then go back and to appreciate why a decision was a good one for one item, for one client, of many, that's a lot for them to remember.
Yeah.
So-
I thought that nothing should be left in memory, everything should be simply recorded, isn't it?
It would be very time consuming to ask stylists to note why they make every decision, right? So we keep track of the items, like we keep logging data of how they're interacting with the items, what they're looking at in more detail, but we don't do things like ask a stylist to write notes to us about why they chose every item.
Right, but this maybe your job actually to give them enough metrics to
Yeah, and we give them many metrics, but again, it is useful to give people feedback more quickly, just in general, as a principle of human learning. Giving feedback directly after making a decision has a bigger impact than giving it to them long over time. That's one of the key differences between humans and computers. Computers, you can give feedback, like it doesn't matter if the computer doesn't run for a week or two. For humans, we learn better when we get feedback directly after making that decision. That's just how people work. Yeah.
So I assume you guys are doing better than both Amazon and Netflix. My question is, what kind of technology stack and infrastructure do you have? And how do you scale it? It's like, not only bigger, it's a huge thing.
Yeah, it's a lot of data.
So what kind of technology stack and infrastructure you could share with us a little bit? Not too much.
Do you want to repeat the question? And just a quick time check, we're at, I think, 35 minutes or so. I
Yeah.
don't know if you want to table questions.
Or you
want to
can
get
answer
through.
my question later.
So that's a little bit off topic, but I can point you, we have a technical blog that we keep. And there have been a couple of entries that have specifically outlined how our data warehousing and our staff looks.
So it's pretty scalable.
Yeah.
Platform, application, and infrastructure pretty scalable.
We have a 20-person-ish data platform, data engineering team who works specifically on things like scaling.
So you are machine learning.
We have an algorithms team, and under that algorithms team, we have data platform, we have core algorithms, we have multiple sort of subheadings, but yeah, on an algorithms team. Okay, so just to sort of give an example and to concretize this idea of testing and training. One of the things you might do, and this is sort of experimental, we've been working on this over the last little while, you might create questions that are relevant to your research question. You might have stylists answer them in some random order, and then you might be able to determine question difficulty. So for example, would this client buy this item? Would this client buy this item, given all of this information that we happen to know about her? And you can do this many times. Estimating question difficulty, that's a computational problem. So the IRT models, you can calibrate using item response theory. So these are basically just latent variable models that take difficulty and participant ability into consideration simultaneously. The simplest version is called a rash model. They can get more and more complicated, but we'll take that as a case example here. And those specifically work on binary data that's like yes or no data. So did she get it correct? Did she not? It considers the number of participants that answer a given question correctly versus the number of people that answered it incorrectly, while simultaneously figuring out how likely that participant was to get that item correct given their general ability statistics.
I'm sorry to interrupt you so much, but at least two main parameters in here. The ability of the item plus price. So is it kind of binary key for you, or you just leave price out?
Price doesn't really, so this is within our experimental platform again, so like our offline setting. We can give as many features as we want, but what we care about is the outcome variable, right? Did they get it correct or
Right.
not?
So price is one of the parameters.
Price would be something that we wouldn't be controlling for. That would be something that the stylist could consider.
Right. So I just am concerned that if the dress is not chosen, it could be just because it was pricey, not because
Yeah.
you didn't like it.
Well, so basically what we're interested in though is that the stylist cannot just consider one piece of information, but that she can figure out which features to wait on when, what is most important for certain clients. For some clients, price is gonna really matter, for some clients it's not, right? And if the stylist is doing a good job of matching an item to a client, she might consider things like height and weight, she might consider price, she might consider color, she might consider whether or not somebody's a mom. These are all different features that we know about our clients and that we would expect to be built in. If for some reason we thought that price was some sort of confounding variable, we could build that into our analysis model and check that. These sorts of IRT, the Rash model specifically, it's basically just a logistic model. And what you end up with are random effects on your subject and your item. The subject is taking care of the between participant variability, right? The item intercepts are what you actually care about. So some questions are going to be super easy, and some are going to be super difficult. And if you actually have variation in item difficulty, what you should get is this sort of slope, right? If there is not difficulty for some reason, these lines will be sort of lined up along that middle axis, and you'll just get these like long error bars on either side, and that basically tells you that your items weren't discriminate. So your item intercepts can be ordered for relative difficulty, okay? So the ones at the bottom left are going to be your easier questions, and the bottom and the top right are going to be your harder. And then when you go to train your stylists, what you could do is you could start them with something super easy, something that everybody got correct, and then end with something hard, something that is relatively more difficult. You'd have your stylist answer these questions in that order, and then you could actually give them, you could track how well they've done on each level of difficulty, so you could also evaluate your workers a little bit better. But you can also give them feedback right away, right? So you can say, okay, you got that one correct, here's what she said about it, and here's why it was correct. The bonus is that this approach is grounded in cognitive research. There's this area of work that's looked at what we call progressive alignment, that basically prescribes that giving people tasks that they're more likely to succeed at, and then progressively making things more difficult can sort of bootstrap them towards answering more difficult problems at a higher rate than if you had just sort of randomly shuffled them. This is particularly good for like structural reasoning problems. But it would work in this sort of case because you're dealing with things like integrating height and weight and all of these other features. Okay, sort of what you hopefully get at the end. I know that was a lot, but if you've actually managed to figure out what your people should be processing, and they are now trained and also working in a more optimized environment, then hopefully this integrative loop works better and you get happier clients at the end. Yeah.
Is there a danger of overtraining your stylists so that they feel as though they're a machine themselves and not creative fashion people?
So
how would you find an overtrained stylist?
So one of the ways we deal with that in general is that we do have a stylist to client matchmaking algorithm. So we want to pair our clients with our stylists with the clients that they have the greatest probability of doing well with. So a little bit of overfitting is okay. The other point that you made though is that making them feel like they're machines. That's something we work really hard at. Is we want to make sure that we're taking off from them the part of the job that they wouldn't want. So they don't want to sit there and calculate purchase probabilities for everything in a warehouse. That's tedious, and I don't know anybody that would want to do that. What they do want to do is feel creative and put items together and write notes and build relationships, and those are the parts of the job. Even if we make them better at it, that empowers them. That makes them feel like they're doing a good job. Nobody likes to feel like they're doing a bad job, right? So by giving them a work environment that's not confusing, that is optimized, by giving them the tools they need to make good decisions, that's making them better, that's empowering. So we talk to them a lot and make sure that the changes we're making aren't messing up their days. And that's that whole exploration, have conversations part. That's definitely part of our ongoing development process.
The stylists don't feel manipulated at all by you making their attention, you directing their attention to certain things?
I mean, every piece of media will always do that, right? So just by making things like color choices, you are being manipulated in some way. we're not manipulating them to do something that they don't want to do. We're helping them interact with their work environment to help them make better decisions. If we were somehow, manipulating our clients to buy things and they feel like, we're not doing that. We're just making sure that the place that they're doing their work is optimized for them. It's sort of like a personalization for their work environment. I know when I go to work, I would rather have my work environment help me do a better job than to fight against me. Yeah.
So is everything trainable? Say for example, so maybe for each and every year, there's gonna be a different session that people love, but how can you train those stylists to predict what the customer might want in the future, considering the future session?
Yeah. There's always.
Do you mind repeating the question?
Sure.
Thanks.
Thank you. Sorry. How do you deal with training and changing things that are hard to train? So like changes of fashion. And I think the biggest example would be we've launched 2 new business lines. We launched shoes initially, so we never offered shoes, so we had no data on how to train somebody. And we also launched men's, which men are sort of fundamentally different to dress than women. So there's still a sort of cold start problem, right? At some point you need data to be able to train, right? So, we can pick stylists who happen to guess well for the initial start. But then at some point you just sort of need data to roll in order to even be able to make these questions and make predictions, to make prescriptions about what they should be doing. So, like anything, dealing with a cold start is something we think a lot about every time we launch a new line. As far as things like changing fashion, style is complicated in general, right? So defining what style is, how somebody feels about their style, how married they are to that style, how it evolves over time, that's all extremely difficult. And that would be another thing that I would say would be really hard for computer algorithms to keep up with, like how somebody changes over the duration of their lives and as far as their tenure with us. So a lot of the time the stylist will, you talk to the stylist and they say, well, I had this client 4 years ago and she really liked edgy stuff then, but now, she had a kid, now she's getting more and more classic sort of looks. Those are things that our stylists are really, really adept at picking up.
What's the error rate that you experienced here?
I'm not sure I'm allowed to say that, because that could, basically I'm not allowed to give anything that could back you into our numbers, and given that this mirrors how they do in real life, I'm going to back away from that question respectfully. Sorry.
So, a range is fine, but can you give a range?
Far better than chance. Far better than chance. Yeah.
So do you guys also take clients browsing data? For instance, if they browse on their computer over time, what they are looking at recently to determine, the computer takes that data to determine what the style is.
So are we setting cookies and sort of tracking?
Yeah.
Not really.
So it's just only based on the website.
What they tell us, the feedback they give over time, they can link us to their Facebook, to their LinkedIn, to their Twitter, in which case we can look at that data, but we do also want to respect people's privacy. A lot of the clients we deal with, they have kids, they have family members. There's also a sort of messy question that as soon as you start doing that sort of cookieing, multi-user computers, how do we know that she's getting, how do we know that the data we're getting is from her and showing her preferences as opposed to say a family member or something? So no, we haven't gone down that route.
What about retailers, Macy's, Nordstrom, etc.? Do you have repeat data from them?
No, not really. Our marketing team is constantly collecting market data, but that's not built into our core styling algorithm or anything.
Any anti-spamming strategy, anti-spam, how do you feel?
Anti-spam?
Yeah. For example, your competitor try to, you kind of labeling, intention labeling a data, or some of the users actually they are labeling data unintentional, which is, so this should be good, but they label as bad or without. Well, this is called anti-spam. It's spam.
So we don't have that. So our website, you never look at it items shipped to their house, given us feedback and sent those items back. That's starting to look like a real client.
What about there are other accounts, created or registered by bots, by the robots? So,
We don't-
so they can automatically create the profile.
So you can filter on somebody that's actually, you can just filter on has had a fix, right? And then you've only got users.
So that's created a difficulty for you to do the computation, because there are a lot of dirty data.
For us, that's less of a problem.
It sounds like you're not getting dirty data, though,
Not
because
really.
you already know, based on the problems, what's going on there.
Yeah,
There's no question.
Yeah, that's, I mean, especially at the point where somebody's had something just shipped to their house, that's,
Yeah.
I don't know which hand is up first, self-select.
Yeah, but now bot can do anything, bot can do shopping, so, so.
Ours is.
Later on, you're gonna have to, not now.
Yeah.
The question about the fashion trend or acceptance based on historical data. You obviously have the past purchase or acceptance data from your customers, what they like. But I mean, based on 2 years ago, and everyone likes a certain style, and now it's definitely not something they want.
Yeah.
So how do you try to compensate for that, or how do you actually do that?
We do think about that. So we also, our business is interesting because we are both a tech company and a retail company. So we have content developed, like content specialists who go to like Fashion Week and like bring back samples and are constantly trying to stay apprised of current trends. So we don't have the same merchandise available now that we did 2 years ago, right? So we make the best recommendations of our inventory at a given time, which changes dynamically with time as well.
But inventory is adjusted to your algorithm, or you adjust algorithm to the inventory?
The algorithm will only show items that are available in the warehouse at a given time.
So the buyer, who purchases all this inventory, what is his input? I mean, who provides input for him?
So we have a merch data team who, so this team does a lot of really interesting things. They do forecasting about what might be wanting to be bought at a given time. They do like client segmentation. And then they also do things like we have exclusive brands. They use genetic algorithms to design new clothing based on what has been popular and what's worked in the past. So we take that data stream all the way through to our buyers.
So when you optimize your algorithm to choose these 50 items, so you optimize it for the profit. Do I understand correctly? I'm sorry to be.
We don't optimize for profit. We optimize for delighting a client. Like we would rather have so if we make a prediction and we send you something and you happen to own it, but you loved it and you are super excited that we got your style to such a degree that we sent you something that you already owned and you want to come back and try it again, but you only buy 3 instead of 4 items, or for example, we're just as happy with that. We want lasting relationships. We want clients that love the service, get delighted every time that they receive a fix. So we're not necessarily optimizing on overall profit. We're optimizing on a good outfit, on the client being happy, on her having really high fit style ratings, those sorts of things. I think that handles.
Yeah, so what is the average cost of an item on your website? Or if you like, what type of demography you target? Is this?
We've been pretty committed to being broad, like to being for every woman, and now every man. We're not really targeting one particular demographic. We aim to serve everyone.
The busy ones who don't have time to shop.
Do you find that your customers like to give you feedback?
They love it.
They do.
Oh my God, they love it.
And
Yeah.
you don't need to give them incentives. They just like to talk. And
They love to give us
why is
feedback.
that? You study behavior. Why is that?
I think it's the level of investment. So you've taken the time. Somebody has written, like all of our fixes, all of our shipments come with a handwritten note, or hand-typed note anyway, it's printed. A note written by a human being that explains why something was sent to you. Our clients have figured out that they get better predictions the more feedback they get. And at the point that you're only getting 5 items and you're excited for those to come, you want them to be really good. Like they're disappointed when something goes wrong. So they're smart. They've figured out that better data makes better recommendations.
Okay.
Well, there's probably.
Yep.
You can, I'll go second.
Okay, feel free to speculate. No? Okay. Okay.
Okay, how do your algorithms help the stylists manage the large inventory? I assume you have very large inventory.
Yeah. So the initial parse down from many SKUs is done by an algorithm. And that's got a bunch of features that make the best guess out of X number of items, a much lower number. I said like around 50 plus or minus whatever, that the stylist can then choose from. She can't access everything. Like
Right.
we take that decision away because if we know, for example, that you're a size 4 pant, why on earth would we show you a size 16? Right? That's just unnecessary filtering that human would have to do. So the algorithms take care of stuff like that.
But even with after you filter those things out, the possible numbers of items you can.
We show the
person
top
can
ranked
manage.
items, right? So they're recommendation algorithms, like any recommendation algorithm, and you can order based on probability of sale, say, or most similar to the client, or whatever metric it is that you want to optimize for, and then you just take the top items, right? The top 50 items or whatever, and you display those.
That can suffer from this bias of the system, right? You only show things that you've gotten some you've shown before and done some feedback. So is there any mechanism
For new product.
New product and also for the stylist to actually explore within the system very easily, right? So let's say if there's something in mind, they can actually go into your inventory and look for the particular item that's very similar to what they have in mind.
So this is an area that we can think about that we're sort of researching going forward is what is the payoff between giving them an unlimited amount of freedom and bogging them down, right? So it's something we're working on.
Well, they don't have to start from scratch, right?
Right.
Start from some small set first, a smaller
Yeah.
set.
So they can do things like filter on. So let's say you want a black dress. You can say, okay, I'm going to go only for dresses, and I'm only going to go for black dresses, and then you can sort of filter it down on that. If what you want is still not there, it might not be an inventory, right? Like we might just not have that, so we don't want to give them access to every dress that we possibly have in us and sort of filter through it. There are some decisions that we, as researchers, have to sort of just make, and say, okay, find the optimal of these options.
I have another question. How do you deal with features that are not observed? For example, let's say a stylist can do a really good, propose a very good ensemble for a client. But under normal, let's say you don't know anything about the client. Well, given whatever you know, it's probably a very good fit. But there's some other information out there that you couldn't observe that would make it a very bad fit. For example, let's say the client's coworker has the exact same thing.
Yeah.
I mean, that would make it a terrible fit for that one, but not if the coworker didn't have that. It would have been a perfect fit.
I think this is a problem for every recommendation, right? So like you go on Amazon and it tells you books you might like. It doesn't know what's sitting on your shelf necessarily, right? So we're constantly thinking about new data to collect from our clients. We're constantly like sending out more surveys and constantly iterating on our onboarding survey. Our algorithms team is constantly generating things that are like, if we have this data, we think our predictions would go up. Can we start asking it? I mean, we take R&D very seriously, so we're constantly looking for better data.
So there's really no way to do it.
There are always unknowns. There are certain things you're never going to be able to know, and I think that's just like the recommendation system is always going to be attached to some amount of uncertainty. Just do the best you can with the information you have.
Did you try to do the whole process till the final selection of, say, 5-6 items based on your algorithms rather than give last 50 to the person?
I'm sorry, what?
So you choose 50 items to give to a person. Have you tried to do final selection just algorithmically?
We're not interested in it. As a company, we think the humans have something to offer.
That's correct.
And
I was
we employ a lot of like working moms and like women that are taking care, like we haven't even considered taking them out of the loop. That's not something we're exploring at this time.
Question about
Yeah.
another dimension of human behavior. Are your stylists paid by the hour or by the number of cases done
By the hour.
by the hour?
Yeah.
Okay.
And they are employees, they have benefits, they have we take them as employees. Yeah.
So kind of up on the hour. So I don't know if you're going to be sticking around a little bit if anyone else had extra questions. But,
Yeah.
okay, cool. Well, thank you, Catherine. Really appreciate you coming out. Cool. So yeah, so everybody, thanks for coming. Please come and talk to me if you have suggestions for future speakers, topics you like. But yeah, thanks everyone again for coming. Thanks again.
Thank you.